Question is, suppose a consumer has a utility function that is u of x1 comma x2 is equal to x1 raised power 0.5 times x2 raised power 0.5. x1 and x2 are the two goods. The prices that he was initially facing for these two goods are price of good x1 is $1, price of good x2 is $1. Okay. Initially he has an income of $100. Assume that the price of good one has increased to $2. Okay. While all other things remaining unchanged. We need to find out the additional money that should be given to the consumer to make him as well as he was previously in utility terms. Okay, how much additional money do we want to give him so that he is as better as he was previously? We need to find out that very, you know, quantity of money. Okay, what is our utility function initially? So our utility function is, let me write it here, u is equal to x1 0.5 can be written as under root 5, sorry, under root here, and x2 can be also written as, exponent can be written as under root sign with. Now initially what is initial price is $1 for good x1, initial price for good x2 is also $1, and initial income is $100. Okay, so we need to construct the budget constraint. So budget constraint is simply P1 times units of good 1 plus P2, that means price of good 2 times units of good 2 should be equal to income. So P1 and P2 are 1. I can write it in this fashion, x1 plus x2 should be equal to initial income is $100. First, if I can make also the graphical, thing here, let me try to. I am not sure I can do it clearly. And so we have units of x1 here, units of good x2 here. So what our endeavor is initially we want to maximize this utility function subject to this budget constraint. Okay, let us say this is our initial budget constraint. Okay, now the optimal bundle, as you know, will lie where the indifference curve and budget line are tangent to each other. Okay, that means if we have this very graph, it is indifference curve, they should be tangent to each other. Let us say this is the point of tangency. I'm not drawing the indifference curve. Okay, so at this point or at this point our M or S should be equal to the ratio of the prices. That means slope of the indifference curve should be equal to the slope of budget line. Okay, so we have for maximization, okay, we know that for maximization our MRS between good 1 and 2 should be equal to the ratio of prices, that means P1 upon P2. MRS is nothing but marginal utility of good 1 upon marginal utility of good 2. It should be equal to the ratio of the prices. And marginal utility of good 1 means the partial derivative of utility function with respect to x1, and marginal utility of good x2 means the partial derivative of utility function with respect to good x2, and it should be equal to the ratio of the prices P1 upon P2. Okay, first we need to find the initial bundle, optimal bundle. So du upon dx1 means the derivative of this utility function, and let me write it here. We have u is equal to under root x1 can be written as x1 raised power 1 upon 2, x2 raised power 1 upon 2. Du upon dx1 means the derivative of this function partially with respect to x1. So we have exponent 1 upon 2, it will become coefficient x1, and exponent will be subtracted by 1 by power function rule. It will become minus 1 upon 2. x2 will remain same, 1 upon 2, because we are taking derivative partially with respect to x1. By the same logic, du upon dx2, that means marginal utility with respect to, that means the partial derivative of this function with respect to x2 will be so the the exponent becomes coefficient of x2, x1 will remain as it is, and x2 its exponent will be subtracted by 1, so it will become minus 1 upon 2. So du upon dx1 divided by du upon dx2, if I divide it here, you can see here 1 upon 2, 1 upon 2 will get cancelled. If I transpose this numerator to denominator and this denominator to this numerator, what happens? So we have x2 in the numerator, x2 raised power 1 upon 2. If I transpose this also, it will get multiplied and exponent sign will change. It will become plus 1 upon 2. And in the new denominator, we have x raised power 1 upon 2. If I transpose this numerator to denominator, its exponent sign will get changed. It will become positive 1 upon 2. Bases are same, we can add up the exponents. Here bases are same, we can add up the exponent. So here we have x1, sorry, okay. So here we have x2. Now 1 upon 2, 1 upon 2. When we add them, it will be equal to 1. Here also the exponent, when we add, it will, be equal to 1. So that means du upon dx1 divided by du upon dx2 comes out to be x1 upon x2. That is our Marner rate of substitution. So I can write x1, sorry, we have x2 here. Galti balai chhi gasan kabar kya chamut az. So we have x2 divided by x1 is equal to ratio of the prices P1 upon P2 is 1 upon 1. So we will get 1. Okay, let me rub this out now. Which gives us x2 should be equal to x1. Okay. We plug this into the budget constraint. Okay. Plug x2 is equal to x1 into the budget constraint. This is our budget constraint. So we have x1 plus, in place of x2, again we have x1 is equal to 100. That means twice x1 is equal to 100, which implies x1 will be equal to 100 upon 2, which is equal to 50. Okay. And what will be x2? Since x2 is equal to x1, that means our x2 will also be equal to 50. Okay, so we found out the initial bundle here, x1 and x2. Now what is the initial utility that the consumer is getting? Simply plug. So utility that the consumer will be getting, simply plug the value of x1 and x2 into the utility function. x1 is 50 and x2 is also 50. Under root times under root, it will become 1. So we will get utility that the consumer is getting initially is equal to 50. Okay. Now we are being told, assume that the price of good one has increased to $2. Let us say price of good one increased to $2. Price of good 2 is same. Okay. We need to construct the budget constraint again. So we have P1 times x1. P1 is 2, so I can write 2 times x1 plus price of good 2 is same, so we can write it x2 should be equal to m dash. Why? It will not be equal to 100 because price of good 1 has changed. This is our new budget. This is our new budget for the consumer. Again, optimality requires our M or S should be equal to the ratio of the prices. That means P1 upon P2. MRS we calculated, it came out to be x2 upon x1. x2 upon x1 should be equal to P1 is this time 2, P1 is 1. That means x2 will be equal to twice x1. Okay. Let's plug this again into the new budget constraint, the value of x2. That means we have twice x1 plus twice x1 in place of x2 should be equal to m bar, which is 4x1 should be equal to m bar, which means x1 will be equal to m bar upon 4. Okay. And what will be x2? x2 will be equal to twice x1. x1 we got m bar. So we have twice, in place of x1 we have m bar upon 4, which gives us x2 will be equal to m bar upon 2. Okay, we have this very optimal bundle, this very optimal bundle. Okay, now what we need to do, the question has asked us, assume that the price of good one has increased to $2. Okay, we constructed new budget constraint here, while all other things remaining unchanged. The additional money that should be given to the consumer to make him as well as he was previously in utility terms. Okay, how much money extra that we want to give to the consumer so that he feels as better off as he was earlier, okay, in utility terms. Initially, how much better off he was? Okay, initially he was getting a utility of $50. 50 utilities, I cannot say dollars here, sorry for the mistake. Okay, we need to find out how much extra money do we want to give him. For that, what will we do? This is our utility function. U is equal to under root x1 times under root x2. Price has changed. We want this consumer to remain as good as he was previously. So previously, how good he was? 50. So in place of utility, we write 50 utilities initially he was getting. And we plug the new values of x1 and x2 into utility function. That means in place of x1, we have this m bar upon 4 under root, and in place of x2, we have again m bar upon 2. So this will become under root m times under root m, it will remain m bar, and under root 4 will become 2, and this will remain 2 under root 2. That means our new income will be equal to multiplying this with this, so it will become 100 under root 2. Okay, see here what is happening. Okay, we need to give the consumer, that means new income should be equal to this very much amount. Okay, but we need to find out the additional income. Okay, so the extra income that we want to give to the consumer so that he feels as good as he was earlier will be equal to the new income, that is m dash, minus the initial income was m, which is equal to 100 under root 2 minus 100, which comes out to be 41.42. That means we need to give to the consumer $41.42 extra so that he feels as good as he was initially when the price of good x1 has increased. Okay, now let me explain it with graph, it will make more sense. Okay, so the question is like this. We have units of good x1 here, units of good 2x, good 2 here. Initially, this is our budget constraint. Let me draw it in this fashion. Let us say initially this is our budget constraint. Okay, we initially find out the initial optimal point. Initial optimal bundle will be at that very point where indifference curve, and if I draw here indifference curve and budget line, the tangency condition will give us the optimal bundle. Okay, now the question tells us the price of x1 has increased to 2. When the price of x1 will increase, quantity of x1 will obviously decrease. Let's denote, that means the budget line will pivot. Let us say it pivoted in this fashion. Okay, initially this is our budget line. Now the budget line will pivot towards left because the price of good x1 has increased. Quantity of x1 will decrease obviously. The question was telling us that how much extra money that we want to give to the consumer so that he feels as good as he was earlier. Okay, so for that what we do, we simply shift this budget line. Okay, so consumer has this very budget line here will be also tangency condition, and we have nothing to do with that. To make him as better off as he was earlier, we shift this budget line towards right in parallel. Okay, let us say this is the parallel shift of the budget line. Okay, I have told you I have not drawn the indifference curve with the purpose here. Now I can draw when I have released this income. I have given him additional income. That means we will have the indifference curve in this fashion. That will look like this. Okay, this is our indifference curve. We want how much extra income that we want to give to the consumer so that he is back to this indifference curve. Initially he was at this point. Okay, price of good x1 has decreased, so he will be here somewhere, will be some indifference curve. Then the question tells us how much extra income that we want to give him. That means this budget line should shift parallel. Okay, it will shift in such a way, since we want him to be as good as he was initially. So this indifference curve, let us say it gives us 50 utils, obviously. So 50 utils will be here, here, and one point will be also here where this tangency condition is met. Okay, so we shift this budget constraint, and here we apply again the tangency condition, and we found out that we need to give him extra $41.4 so that he is as better off as he was earlier, because he is on the same indifference curve. Okay, I hope I make myself clear. Thank you.